This recording is to demonstrate how to use the AutoDock PyMol viewer to search through the results from PyDock to find the best model. In this case, we're looking at the mitochondrial pyruvate carrier 1 and 2. So for a wild type, I had determined this to be the best model, fitting the literature and everything else that was predicted, and done a bunch of work with it. So we have the PyMol viewer open here on the left, and then this is just the folder you can drag and drop into there for that. So I'm now going to click on another folder. This is a result of the PyDock to take the two monomers that can be seen here, receptor and ligand, the MPC1 and MPC2, and then generate predicted heterodimeric molecules. So over here in the Python viewer, I want to click on this to display the ribbon, and then I like to color them. So color by chain, and then the secondary structure. That lets us see this. So the MPC2 has a characteristic hanger type of extension on it. You can see that right here. So I always orient that in this fashion. It's important to note, if we do the display label residues, that for the MPC2, the N-terminus is directed upward toward the intermembrane space of the mitochondria, and then the C-terminal, it would be on the opposite side of the inner mitochondrial membrane. This would be the matrix portion. Note that MPC1 is the opposite. Here's the C residue 109 at the top, being the mitochondrial intermembrane space, and then the N-terminus projected in the opposite direction, but still it's obviously sticking up. But anyway, that's the orientation. They are opposite. Other things that's critical is here at the edge of the MPC2 and MPC1, we can see a cysteine 83 residue. This should be on the MPC1, and that transmembrane spanning helix, that should be close to the cis 54 on the MPC2 on that transmembrane spanning segment or helix. And then internally in the ligand binding pocket, where pyruvate would bind, we see the cysteine 60 and cysteine 61 and the ASN 33. The ASN 33 is one of the binding sites as the pyruvate is passing through here. It's a key binding site. So these are key components of the structure that we want to look for. Fortunately, with this run in PyDock, the MPC2 chain, because it was loaded up as the receptor, and then MPC1 as the ligand in the context of that web page. So the MPC2 aligns just right. So I've the way to find the best fit, I'm in the wrong window, is you start at the top or somewhere and just keep going through, and you drag and drop. You can see when I find one that's of interest, I make a copy of it just as a landmark, or sometimes I do that just to keep track of where I am going down through here. It can take quite a long time to look at each one of these. Unfortunate situation in this one is I'll drop in this one here. I've got multiple copies. None of them oriented just right. Now I can do the ribbon for the one I just dropped in. So you can see the MPC2 is a complete overlap. right? There's our hanger. And then we can see it almost looks like this is just right, but when we hide the original molecule and we come in, we see the cis 60 and 61, but actually you'll find that it's oriented in the wrong way. So here's the cis on MPC2, right? And there's the 60 and 61, but over here on this helix of MPC1, we don't have the cis residue. It's over here on the opposite side. So the problem with this one, and it was the case for any of these best fits, is we have an inverse arrangement of the MPC1 onto the MPC2. So I really didn't find a best fit for any of these. What we have to understand is that we're using an algorithm to generate these images, these 3D protein files, and in reality there are proteins in the outer mitochondrial membrane called TOMs. There are some proteins in the the mitochondrial intermembrane space that help to pass them from the outer membrane to the inner membrane. This protein is assembled, the two monomers, by TIMs. These are proteins within the inner mitochondrial membrane that assemble proteins and then insert them into the membrane if they are to reside within the inner mitochondrial membrane, or pass them through into the matrix and then they're assembled in the matrix. In this case, there would be a complex of TIMs. These are transport proteins of the inner mitochondrial membrane, and that's the TIM, TIMMS, because there's several of them. And then the TOM is the outer mitochondrial membrane, the O. Anyway, I guess these would have to be resubmitted and rerun to try to find the proper one. Anyway, I found another interesting program for aligning these once you have them, and that's at the PDB protein data bank web page. There is a workbench, so you launch this custom structure alignment menu and it will download a Java program. These are some of the acknowledgments, and I'm going to open that now and demonstrate that. So once that's installed and loaded, this menu will come up. There's also an icon placed upon your desktop to open it. Anyway, kind of standard thing for Java programs. You have three tabs here. Custom files is the one we would have to use because we are generating our own custom files. We're not using ones from the RDB website, or the PDB website, excuse me. So you just click on choose and go through the file folders to find them. So here I'm comparing my wild type of this project and the number there to another wild type project that I did. Once you open those, then you run it. I just want to show the results here. You get an alignment like this. You can change the view. You can do some editing to color some things. You can save the text display. With this one, you can maximize. I don't want to do that right now. Let me just adjust it some so you can see it a bit bigger on the screen. You do the file, export the PDB, and very conveniently that will export both of these after they've been aligned into a common file that you can later call into. I'm going to delete these two. You can go into the folder, go back one more. Here, I got it here in alignments. Yeah, so here's one that I had saved. And you can open it here in the PyMol. Again, you can do the ribbons. To view them, you can color by chain. Right. You can identify MPC2 by the hanger hook. Right. So I didn't get a perfect alignment of those, but anyway, it lets you do a comparison of these. And then it's possible to come over here and you can hide these. Right. You can also delete one. I think that was the wild type that I just deleted. You'd have to go in and check. I'm running out of recording time, so I'm not double checking, but you can delete one. Then you can do a file, save, write the PDB, browse. I'm just gonna this would be the 07. I'm just gonna do that. You know, browse, make sure you know what folder it's going into. Anyway, this is going to a different, and then you click OK. Then we would have this exact same one. What's convenient about that is when we come in here for AutoDock, start my AutoDock tools. And we're going to do our grid. All right. Get our grid box. We can use very similar parameters over here to center things. So I like this alignment tool. It gives other data as well. The text data is dumped out. We'll have to do some investigating to understand the true value of that to compare our mutations, the SNPs. But anyway, this video takes you through both of those. Unfortunately, the PyDock run didn't give us a good fit for the L79H SNP. So we'll have to figure out how to manage that. But anyway, it demonstrates how you drag them in one after another to try to find the correct orientation. Just quickly, I'll show that there's there are several others that don't hit at all, right? So here you can see it's totally wrong, right? So this is the MPC1. In that case, the one we just dragged in, this is the MPC1. So they're not even a close hit at all. So you just keep doing that. You delete. You've got, this should be the wild type up there. And then you go to the next one, and you see it's kind of close. If you're not sure, you go to the ribbon. But again, you always have to check of what's in the core, that the sys 60 and 61 are pointing in, and that this long ribbon here is on the other side, not the side of the hook, but on this side of MPC2. And that was the problem for some reason on this one. It just wanted to keep pasting it upside down. Anyway, I'm going to stop there.